Using graphs to relate to quantities is where we're just getting a general feel for the graph. We're not talking about specific quantities, but wanting to see the overall shape and how the variables relate to each other. Our target for this lesson is I can represent mathematical relationships using graphs. So here are some terms that you've heard before, talking about independent variables and dependent variables. What the graph does is it can represent the relationship between two variable quantities. Now let's stop here. Relationship, we're talking about how they change. And with variable quantities, we're talking about things that can change. So if you are working down at the Dairy Queen, things that are going to vary is how many hours you work and how much money you make. And so that would be an increasing graph, because as your hours that you're working increases, so does the amount of money that you make. So we're looking at how these things change. Or it could be, another one could be, let's see, how many cheeseburgers you eat. The more cheeseburgers you eat, is cheeseburgers per day. The more of that you do, then your health is going to decline. You could say, not necessarily your weight, but your overall health would decline. So we're wanting to see how these things would change. With your variable quantities, you have the x values and you have the y values. They may not always be labeled as x and y, but whatever variable you're choosing, x, w, c, y, whatever it is, the independent variable is going to be graphed on the x-axis, and your dependent variable is going to be graphed on the y-axis. So your independent variable, that's the one that's making the change. In our working at Dairy Queen example, the number of hours that you work is your independent variable. It affects what your pay is going to be, how much money you're going to earn. And looking at the other side of it, the money that you earn, the dependent variable, is dependent upon how many hours you work. So let's think about like a 2x4 board, a wooden board. Here's a graph showing that as time goes on at, let's say, 10 minutes, 20 minutes, 30 minutes. Notice there's no specific times, but as time goes on, the length of the board is changing. So you have, it's a constant length. It's constant because it's flat there. And then something happens here and the length of the board goes down. It's the same length of the board, and then boom, it gets shorter. The board is the same length, boom, it gets shorter. And that is happening over and over again. This situation that's going on, that board is being cut off. That's how the length goes down, is that board is being cut. So what are the variables in each of these graphs? What are the things that are changing? Well, that's the length and the time. The length is changing, see how it's going down, and the time is what's changing. It could be after, a minute, after 2 minutes, after 3 minutes. That time is changing. How are they related at various points on the graph? So let's get a pen going here. That's a line. I want a pen. Okay. From here to here, this is a constant length. Okay, and what's happening right here, right here, right here, and right here, at all of those points where the length starts to drop off, the board is cut. So that's showing what's happening there. Now, how this one is staying flat and it's not being cut again, this means that you have probably the desired length there. It's not being cut anymore. That's what's happening at those points of the graph. If you can point out what is actually happening in real life on the graphs, then that means that you're completely understanding that graph. Another task that you're going to be doing is matching tables and graphs. So, key components in this, key things that you're wanting to look at on a graph, either when creating that graph or when you're trying to match them or interpreting a graph. First, what are the axes labeled? So each of these, and this is choices of matching this table to a graph, it's the amount of sunscreen and the number of uses. You have starting points, the ending point. Is it rising? Is it falling? Is it constant? Is it gradual, or is it drastic change? Those are some things to think about. The situation here says the table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? So this is in ounces. At 0 uses, there's 5 ounces in there. If you look at each of our graphs, they're all starting at the same amount. After 1 use, it's going down by 0.2 ounces. So it's not really that much of a drastic change. This is going to be more of a gradual change. So here, it's going up by 1 use. So the amount of uses is increasing. Whoopsie daisy. From here to here, it's also going up. That's a plus sign, 1 use. And the same thing here. It's going up 1 use. However, on the amount of sunscreen, from here to here, it went down by 0.2 ounces. Here, it went down 0.2 ounces. See how that's the same change? And here, it also went down 2 ounces. So the amount of change is the same. So which one would it be? Let's think about these key components. The axes are all labeled the same. They're all starting the same. Let's look at their ending point. For choice A, it's ending up at 0 ounces of sunscreen left. Did I run out of sunscreen? No. I ended with 4.4 ounces. So it cannot be A because of this part right here alone. Now look at this other one. This would be like, let's say that's 5, and kind of eyeball it. Like right there would be, you know, about 2.5 ounces if you're looking halfway. Did I fall below 2.5 ounces of sunscreen? No. I really only went down a small portion. This is showing a drastic change. They're using a lot of sunscreen. So it's not going to be that one, which leaves C. Now let's look to see why C is correct. Notice how the amount that I'm going down on amount of sunscreen is, you know, pretty much the same amount each time. It's a consistent change going down 0.2 ounces. I'm ending a lot more than empty, not much less than full, which is what happened on the table. So that is a gradual change. There wasn't much of a change between those. So the correct answer would be C. Now for sketching a graph, keeping those same key components in mind, at labeling the axes, the starting point, the ending point, rising, falling, or constant change, gradual, or drastic change. So if we're going to draw a graph, I need an X and I need a Y axis. This is all in quadrant 1. Everything is positive because what is happening here is your pulse rate. Your pulse rate would never be negative. So what are the variables in this situation? The pulse rate is one of them. As you watch a scary movie. So what is that second variable? The second variable is time. As I'm watching that scary movie. Pulse rate. Okay. My pulse rate is dependent on what's going on in the movie. As something really scary is happening, my pulse rate is increasing, and as it's more of a calm, something going on, my pulse rate is more even. And that variable is the time in the movie. Picture the DVD player and the excuse me, the ticker on there that's showing how much time has passed. So we have our axis labeled. So we need a title because we want our graph to talk. So this is pulse in a scary movie. Okay. So starting point, would my pulse be at 0? Well, let's hope not. I hope I'm not dead. So let's let my pulse start about normal. So if you think about what's going on in the movie, starting off, it's pretty normal. Let's get rid of that dot there. Okay, you got the opening credits. Everything's going on normal. They're building up the story. You know, my pulse rate might go up just a tiny bit. And then something scary happens. Some creepy guy jumps out of the bushes. Bam, my pulse rate increases. And then, okay, I'm calming back down. Then something scary happens again. And then I'm calming down. And then, oh my gosh, it's, you know, as your literature teacher would tell you, it's the climax of the movie. And then everybody's happy in the end, and my pulse rate is back to normal. It looks very similar to how those diagrams you draw in literature. I don't even know what those are called. You need to tell me that tomorrow what those are called. Where the plot diagram, that's what it is. But you see, as time goes on, your pulse rate is changing. There are no exact amounts. I don't have you know, at a pulse rate of 80, or I don't have that there. It's just kind of a rough graph of what this would look like. That's why it's called sketching a graph.